Hi there, Tim with Madrona Labs, back with another video in our Kaivo series. Today I'm really excited to finally dive into the granulator module, which is basically the foundation of Kaivo. More specifically, it is the nerve center for sample playback, and it's the closest thing to a traditional synthesizer oscillator within Kaivo. So how does it work? The granulator takes any of the audio that you load into it. So as you can see right here in this window, we have a sine wave and creates grains or smaller subsections of that piece of audio. If the grains are small, they can be played very quickly, creating sustaining tones, while larger grains play a larger section of the audio. So the size or width of the grains that is created by the granulator is determined by the overlap, the rate, and the pitch. So why don't we turn the volume up and listen to how each one of these parameters changes the sound. Starting with the overlap, we control how many grains can be active at a time per voice. The rate controls how many grains are created per second per voice. And finally, the pitch control determines the playback speed and the basic pitch of each grain. So you can think of the granulator as a kind of array of a bunch of different samplers working with the same source audio, but each manipulating it in its own way. Each individual grain, of which there can be dozens active at a time, can be set to play at a specific pitch, starting point, looping state, and so on, even when they're being created hundreds of times per second. So up until this point within the video series, we've seen how powerful all of the modules are in Kaivo. But now that we are talking about the granulator, we can really understand why Kaivo has such an expansive palette of sounds. So in the grand scheme of this instrument, you can kind of think of the granulator as the starting point of a choose-your-own-adventure story, because it makes sound on its own independent of the resonator and the body modules. However, it can be used as the mechanism that strums or plucks the resonator and body. So in other words, your choice of sounds to be loaded into the granulator and then how you use all the other modules with each other has a profound effect on what the final outcome is going to be. And what's more is there are no wrong moves. Now that we have a general idea about what the granulator is, let's dive into some of the specific controls. So first up, we have our waveform display. Under my cursor here, you see this window with a waveform in it. I can go up to my oscillators here. I'll pick a sine wave. Now we see a nice full sine wave there. However, if we upload a multi-channel audio source, such as my raccoon fight I loaded into it on a previous video, then each separate channel has its own row within the window. And you can see, because it's a stereo channel, we have 2 rows of sound. And within our viewing window, we have X and Y axis sliders, which allows you to set the center point in time from which the grains are created. And any incoming modulation data will basically move this slider before or after that starting point. Then we have the Y or vertical axis slider here, which lets you set the center point in the vertical stack of audio channels within your sound source. And then incoming modulation data will move this slider above or below the point at which you set it. So in summation, the Y-axis is not going to have an effect on any mono signals that are uploaded into the granulator. And finally, the position of each currently active grain is shown here with these light vertical lines overlapping the waveform. So really quick to review, the X-axis controls where in time the grains are created from, and then the Y-axis selects the grain's position within the stack of audio channels. Another feature of the X and Y sliders is the visual feedback provided when you put in a modulation source. So here I've put the LFO into the X-axis modulation input. You can see this line here going back and forth before and after the point at which I set the X-axis slider. As you may have noticed by now, we have the name of whatever sound source we have uploaded into our granulator, and when you click on it, it opens up your source menu, where we have a bunch of sounds that come within Kaivo, but you can also upload your own. To import your own sound into the granulator, simply select the source menu and go to Import, and then you will see a directory come up, and then you can just pick your sound from there. And while you can import just about any length of audio file, it's going to be truncated to 8 seconds within the granulator. Keep in mind that any grains that are currently active when you choose a new sound or patch, those will continue to play their portion of the previous loaded sound until they expire. But this is actually good because it allows for seamless transition between different audio sources. So why don't we take a listen to what that sounds like? So here's my raccoon fight sample, and now I'm going to go to a sine wave. You can hear that fade out, and now back to the raccoon sounds. You could hear the ending of the sine wave overlapping with the beginning of the raccoon fight. So as I stated before, the pitch control allows you to set the playback speed of the grains. And when working with longer grains, this dial and its inputs are the way to set the pitch. You can see that the default on the larger pitch dial here is at 0. That is the natural pitch of the source audio. And changes made in this dial are done so in octaves. So you can go up to 3 above or 3 below. And just a reminder, if you hold Shift while you turn your dials, you get a more fine control. There are 2 inputs for the pitch dial. There's an exponential and a linear. The exponential in is for use with the sequencer or an external MIDI controller, and that is why the Kaivo default patch shows up with the pitch output from our key module going into the exponential in. And then the linear input is for linear frequency modulation. The positive, negative, smaller dial here, this lets you dial in a positive or negative going amount of pitch envelope or mini envelope that controls the pitch trajectory of the granulator over time as a linear ramp from 0 to the dial setting, and has a range of -2 to +2. Before we move on, I'm going to start a simple patch to build on throughout the video so we can take a listen to all the different parameters that we talk about during the video. So to set this up, I've got our sequencer running and the 2 gate outputs set at a delay from each other to reset the LFO, trigger the noise module, and trigger the envelope 1. The envelope 1 is triggering our gate, which is allowing our sound to come out. Now I'm going to take one of the outputs from the sequencer for our melodic line and put that into the pitch input. I'm going to take that same output and put it into the rate. Now notice the difference in sound once I put this into the rate. So I really want to stress that when using the granulator as your voice that is going to be carrying your main sequence, to use your sequence on both the rate and the pitch. Now let's take our noise output and put it into the exponential FM in and slowly start bringing that signal in. Now I'm going to take the Y output from our LFO and put it into our plus-minus input. Continuity error. Yeah, I changed my shirt and I shaved my beard. It's a new day. We've talked about it, we've moved on, and we're never going to speak of it again, all right? Now we're going to talk about the trigger input on the granulator. As I mentioned earlier, grains are created automatically at the rate that you have set on the rate dial. If you turn the rate all the way down to 0, then you're not getting any grains firing. But using the trigger input allows you to create new grains every time a signal is received. So let's put a gate signal from our sequencer into the trigger input. Each one of these new grains created by the incoming gate signal has a bit of attack added to the beginning of the grain, so it allows for smoother sounds. So each new note in the sequence can start nice and crisp. When setting the rate to 0 and using the trigger input to fire off new grains, all of those grains are going to stay at their starting pitch until they expire. However, with the follow button, this allows the pitch information that's being sent to the pitch input to have an effect on each grain's pitch from the starting to ending point of the particular grain. So let's take a listen to the difference between having the follow button enabled versus disabled when I have pitch information being sent into the granulator. So here it is with it disabled, and now I'm going to enable it. We touched on the overlap a little bit earlier, but let's get into it specifically now. The overlap lets you select how many grains are active at the same time. Here our rate is set at 220, meaning 220 grains are firing per second. And now I'm going to turn up the overlap dial so you can hear how it changes the sound. So as some of you may have probably figured out by now, if the rate is set at 1 and the overlap is set at 1, then we have 1 grain firing per second. And then to the right of the follow button is our sync button. What this does is it snaps the starting position of a new grain to the nearest smooth transition within the wave file. And this helps keep the grain playback in sync with everything else that's going on in your patch. I picked a nice chunky sound to load into the granulator to show off the sync function, and I have placed the X and Y axes in such a way that we are getting a lot of start and stops with our sound, because as you can see here in the waveform window, this particular sound has a lot of empty spaces on both the X and Y axis. So let's take a listen to what it sounds like without the sync on. Nice and choppy, and now I'm gonna turn the sync on. And now check out the and now listen to the difference with the sync enabled. The last button to talk about is the wrap. And when this is enabled, it allows the grains to loop through the source audio continuously. And when disabled, each grain is going to expire when it reaches the end of the audio file. So the grains created while wrap is on will just loop indefinitely until they are replaced by new grains. It's important to note that when using the wrap, you can kind of get into a stuck note sort of phase. And of course, these repeating grains will eventually be replaced by newer grains. You can actually clear that stuck kind of feedbacky almost sound you can get with the overlap control. So let's turn our sound back on and we'll hit our wrap button. And now to kind of clear that stuck note phase, I'm just going to turn that overlap down. And we can turn it back up so you can use, that's just something to keep in mind when using the wrap function within the granulator. Now let's take a listen to our patch from earlier with turning each one of these buttons on and then off. So starting with the wrap. Then to the sync. And then to the follow. I'm going to turn our sustain up a little bit here, because remember, the follow changes the pitch of the already fired grains, if the pitch or the rate are being sent some sort of signal, that is. I'm going to introduce the X output from the LFO2D into our Y input here to control the Y slider of the waveform. And I chose the 4 harmonics to load into the granulator here because it has 4 different channels. That's why I put the LFO into the Y input. That way you can see we are now just scanning through these 4 different channels that are in the waveform. As we discussed earlier, the rate knob controls how many grains are created per second, and when set to 0, you can hit the trigger input. There's actually one more way you can stimulate grain production. Let's set our rate to the default at 220 grains per second. And as you can hear, grains are firing off. Now when I hit this noise button, you can see within the dial, we have a noise signal going in there. What this is doing is using a noise generator that's built into the granulator to modulate the grain rate. The final thing to talk about is very simple but very cool, and that is the pan control. This lets you control the stereo position of each grain as it's generated, and each grain will stay where it is put in that stereo field once it's created. So by varying pan over time, you can create some really wonderful spatial effects. All right, this has been our video on the granulator module within Kaivo. Thank you so much for watching. If you'd like to learn more about Kaivo or the other great synths from Madrona Labs, please visit our website, link in the video description. Thanks for watching.